Okay, so we're going to do the chemistry midterm review guide, which kind of encapsulates everything we've done thus far in chemistry. And let's see, 1 mole of sodium atoms has a mass of, and we can look at our periodic table. 1 mole has a mass of 23 grams. Everybody knows that's the atomic mass of sodium. This number is called the molar mass. This number can always be found on the periodic table, yes. 1 mole of any element contains 6.02 times 10 to the 23rd particles. This number is called Avogadro's number. All right, now we get to the real work. 400 grams of MgCl2 to moles. Okay, so we're starting out with 400 grams MgCl2. And whenever we go from grams to moles of one thing, now remember, when we go from grams to moles of two different things in a reaction, that's when we start doing the boxes. And so we'd have 2 boxes. But here we're just converting 400 grams of MgCl2 to moles. Down here we know these units have to cancel. So we know this is 1 mole MgCl2. And let's see, we got a magnesium. We got to start adding stuff up. We got a magnesium right here, 24.3, plus 2 chlorines at 35.5. So we get a total molar mass of 95.3 grams. And then 400 divided by 95.3 equals 4.197 moles MgCl2. Let's cancel. Moles is all that's left. So we have 4.197 moles MgCl2. All right. How many moles of nitrogen are in 1 mole of NH4 3PO4? So this distributes, and you have to think of this as 1 mole of this substance, and then start looking at atoms. So there'd be 4 moles of oxygen, 1 mole of phosphorus, 12 moles of hydrogen, and 3 moles of nitrogen. I would also accept 1.5 moles of N2 if we realized that it was a diatomic. Okay. How many moles of barium atoms are present in 83.9 grams of barium? Okay, so we have another problem to work. 83.9 grams barium. 1 mole barium. And barium weighs 137.33. 137.33. So 83.9 divided by 137.33 equals 0.610 moles barium. So 0.610 moles of barium. Okay. Convert 1.204 times 10 to the 24th atoms of aluminum to moles. Okay. So what we're going to do here, we'll move this down a little bit. So they've given us 1.204 times 10 to the 24th atoms. Doesn't matter what it's of. We're just going from atoms to moles. There are 6.022 times 10 to the 23rd atoms in 1 mole. So, and everything has to be done in parentheses. So, I'm going to try and show you this. 1.204 times 10 to the 24th divided by 6.022 times 10 to the 23rd, 0.338 moles. So this is 0.338 moles of aluminum. Okay. Convert 1.204 times 10 to the 22nd molecules of CO2 to grams. Okay, so here we have two conversions. We can't go from molecules to grams, but what we can do is go from molecules to moles and then from moles to grams. So we have 1.204 times 10 to the 22nd molecules, 6.022 times 10 to the 23rd molecules in 1 mole. So again, we're going to put it in parentheses, 1.204 times 10 to the 22nd divided by parentheses 6.022 times 10 to the 23rd. So I get 0.019. I'm just going to make that 0.02 moles. And then we have another calculation to do where we have 0.02 moles, 1 mole grams of calcium, no, CO2. So let's see, that's 1 carbon plus 2 oxygens. So that's 44 grams times 0.02 equals 0.88 grams of CO2. So this is 0.88 grams of CO2. How many atoms are in 50 grams of calcium? Well, now they just want me to do the same problem but backwards, basically. So we're going to go from grams to moles. 50 grams calcium, 1 mole calcium, and there are 40.1 grams of calcium in 1 mole. Molar mass again. Calcium, 40.1. Okay, so we have 50 divided by 40.1 equals 1.246 moles of calcium, and then we have to go from moles to molecules or atoms or whatever. So now we're going from atoms. So we have 1.246 moles calcium, 1 mole calcium, 6.022 times 10 to the 23rd atoms in 1 mole of calcium. So times 6.022 times 10 to the 23rd. That gives us 7.51 times 10 to the 23rd atoms. 7.1, oops, try that again. 7.51 times 10 to the 23rd atoms. Okay. Flip this over and I'm going to work upside down so I can be close to the page here. Okay. How many atoms of magnesium are in 6.5 moles of magnesium? Oh, well, that's pretty easy. 6.5 moles. 1 mole, because remember these units have to cancel, always, always. And in 1 mole there are 6.022 times 10 to the 23rd atoms. So 6.5 times 22 times 10 to the 23rd. I get 3.91 times 10 to the 24th atoms. 3.91 times 10 to the 24 atoms. Okay, let's move all this up a little bit. Okay, 1 mole of xenon gas is equal to, well, this is a no-brainer, 6.022 10 to the 23rd molecules. Okay, and we'll continue with part 2 momentarily.